Okay, so how it work for the tidal condition? Tidal coming in, so from the seawater, okay, and then it move, okay, and then during this kind of path, they will rotate the turbine and generate the power, okay, and then when it vice versa and opposite way, they are using the part of this one to enter this part. So this movement will long last since we have the sun and moon, okay, to have this kind of behavior. Okay, so it's a quite consistent in terms of the producing power. Okay, so second generation tidal power plant. Previously we have this barrage. Okay, so this kind of barrage style. Okay, barrage is this kind of barrage. No need, limited total cost, two type, vertical, horizontal. Okay, Davis hydro turbine. Okay, see, still this one, a hydro turbine. We're still using the hydro turbine. Successfully test in St. Lawrence. Okay, so this is the thing. They do not need all the barrage just now. They put it very standalone. Forgo with the low cost approach to produce and to manipulate the tidal condition. Okay, so this is the one. Okay, so they have this kind of strut, and they have also the turbine over here. Okay, with the same concept, by the movement of the wave, okay, then we will generate. Alternatively, the fan will rotate and generate the power and produce the electricity with the same concept of hydropower. Also, the wind turbine, just the method, the medium of producing this rotating fan by the wave condition, the moving of the wave condition. Also, the fluid is a working fluid, is a water. Okay, harness the energy from the tidal stream more efficient because allow for energy production both having the surge tide. Okay, one side have potential to equal generating power of 3 local power. Okay, so this is a very general statement related to the tidal power plant. Okay, disadvantage, I think we can imagine the advantages of this kind of system. Presently costly. Okay, of course, if you want to do this kind of approach, you need to invest term of the depends. If you go for the bearish condition, you need to have the all the depth everything. If you want to have the only the standalone tidal device, so that you have, of course, you need to construct multiple system which worth to invest to get the generated power, or else you may running loss due to the insufficient power generated by compare your investment for the uh, device that you are construct. Connection to the grid. Okay, technology is not fully developed. Okay, this is the thing, because you need to know, you to remember, it's not only the construct the tidal, I mean the turbine, but you need to consider how to install, okay, how to bring forward to the middle of the ocean or the sea, okay, and also how to troubleshoot, how to maintain, how to monitor the performance of each. So that kind of part need to be considered before we go for the fully development of the tidal energy. Barista, okay, produce energy about 10 hours. Okay, barista have environment effect, fish and plant migration, self deposit, local tax change. Okay. Of course, if you are going to install, I would say install or construct your facility to harvest all the energy related to the tidal, you need the space underneath the ocean or sea. It might perhaps will affected the environmental condition underneath the sea, which is from the fish or plant or coral perhaps. Okay, so this might affect in terms of the environment underneath. I mean, yeah, in the part of the underneath of the sea. Okay, of course, when you put the certain strut or barrier or any cross section inside there, it will change a little bit in terms of the flow of your wave. Okay, and also might affect the community or the habitat nearby, which is maybe the fish itself. Okay, the condition of that particular places is not suitable anymore for them to stay. So that's the issue. Advantages, if you are looking for this part, no pollution, in that we are producing all the energy by itself. Okay, no harmful gases. Okay, no noise. Okay, because the wave itself also contain the noise for it run regularly. Okay, so since we have the source of the water, I mean the tidal condition, so we have the continuous or consistent renewable energy resources. More efficient wind because the density of the water, of course, as I mentioned just now, just change of the medium. So knowing that the wind, okay, going one way, okay. So for this tidal, you can harvest in two ways, which is during the forward and backward. Okay, so you can have the continuous rotation from your blade to generate the power. Predictable source of energy compared to the wind and solar. Okay, because you have at all time or the source of the wave or the ocean compared to the wind and solar by the latitude and by the geographical condition. Okay. Second generation means that a standalone of tidal device, very few disadvantages, do not affect wildlife, okay, does not affect deposits, less costly both in building and maintenance. Okay, it's like the only the box of the tidal condition, okay, which they claim are less harmful to the environment because the size smaller and also uh, the cost also reduced tremendously. Okay, wave power. Okay, so wave. So those who are play with the what we call ski, maybe love the wave power. Huh? Okay, I think this one you can read by own. So just want to mention that the world wave power resource. Okay, maybe you can zoom to our country. Where is our country? Macam country ni. Okay, so this oh, this one. So yeah, yeah, okay. So that's the world wave power resources. But then in Malaysia, we are not much using this kind of sources. We just go for the hydropower. Okay, hydropower is not related to the wave. Okay, so wave is different story. Okay, so we are not exploit the things. Maybe I think due to the technological wise, but also for the geographical wise. So that's why we are not into it for the source of wave power to be part of our supply. Okay, potential available wave energy to terawatt for the clean water. Okay, wave market estimate 32 billion. Okay, kilowatt. Okay, so this is the thing. But the concept, as I mentioned just now, still the same. Just the matter, the resource is from the wave, but the conversion From the rotating blade become the generator to produce the electricity. More or less the same principle with the hydropower and also for the green power. Okay, so I think this is up. This up with power design. So I think this one, just go for the concept. Floating device. Okay, they have a few methods. Tapered channel with power. Okay. I think I will go for the video related to this case so that maybe you can have a better understanding due to the condition of the case. Okay, ocean energy, ocean mechanical. Hold on, ocean, ocean. Yes, it's already prepared the tidal one. Tidal. There's a different thing. I think quite obvious lah in terms of the OTEC with, I mean with uh, can you guys hear the volume, the voice? No, okay. I think I know why.
must be at least produce electricity. Tidal electricity can be created through several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses power. Tidal power is a form of hydropower. Tidal power is a form of hydropower that converts the energy from the natural rise and fall of the tides into electricity. Tides are caused by the combined effects of gravitational forces exerted by the moon, the sun, and the rotation of the earth. Tidal plants can only be installed along coastlines. Coastlines often experience 2 high tides and 2 low tides on a daily basis. The difference in water levels must be at least 5 meters high to produce electricity. Tidal electricity can be created from several technologies, the main ones being tidal barrages, tidal fences, and tidal turbines. Tidal barrages are the most efficient tidal energy sources. A tidal barrage is a dam that utilizes the potential energy generated by the change in height between high and low tides. This energy turns a turbine or compresses air, which in turn creates electricity. Tidal fences are turbines that operate like giant turnstiles, whereas tidal turbines are similar to wind turbines, only underwater. In both cases, electricity is generated when the mechanical energy of tidal currents turns turbines connected to a generator. The generator produces electricity. Ocean currents generate relatively more energy than air currents because ocean water is 832 times more dense than air and therefore applies greater force on the turbines. Tidal power is easy to install and renewable, having no direct greenhouse gas emissions and a low environmental impact. Because the ocean's tidal patterns are well understood, tidal energy is a very predictable energy source, making it highly attractive for electrical grid management. This sets it apart from other renewables that can be more unpredictable. However, adoption of tidal technologies has been slow, and so far the amount of power generated using tidal power plants is very small. This is due largely to the very specific site requirements necessary to produce tidal electricity. Additionally, tide cycles do not always match the daily consumption patterns of electricity, and therefore do not provide sufficient capacity to satisfy demand. That's tidal power.
Okay, guys. So that is the very basic related to the reasoning. Okay.
Tidal energy. Tidal power or tidal energy is a form of hydropower that converts the energy in Mahal watching this video. Greetings to Mark and Mahal watching this video. Next Explanations welcomes you. Let us learn about tidal energy. Tidal power or tidal energy is a form of hydropower that converts the energy obtained from tides into useful forms of power, namely electricity. Although not yet widely used, tidal energy has potential for future electricity generation. Tides are more predictable than the wind and the sun. Among sources of renewable energy, tidal energy has traditionally suffered from relatively high cost and limited availability of sites with simply high tidal ranges or flow velocities, thus constricting its total availability. However, many recent technological developments and improvements, both in design, example, dynamic tidal power, tidal lagoons, and turbine technology, example, new axial turbines, cross-flow turbines, indicate that the total availability of tidal power may be much higher than previously assumed, and that the economic and environmental costs may be brought down to competitive levels. Historically, tide mills have been used both in Europe and on the Atlantic coast of North America. The incoming water was contained in large storage ponds, and at the time I built, it turned water wheels that used the mechanical power to produce the mill grain. The earliest occurrences date from the Middle Ages, or even from Roman times. The process of using falling water and spinning turbines to create electricity was introduced in the U.S. and Europe in the 19th century. The world's first large-scale tidal power plant was the Rhône Tidal Power Station in France, which became operational in 1966. It was the largest tidal power station in terms of output until Sekwale Tidal Power Station opened in South Korea in August 2011. The Sekwale station uses seawall defense barriers complete with 10 turbines generating 254 megawatts. Thank you, and please do support this use of the channel. Next Explanations with your valuable subscribe.
Okay, guys. So that's the sample of the brief tidal operational. Okay. So basically, depends how much power you expect to generate, and normally it will be installed nearby the coast. I mean the nearby the sea, right? So by having the gravitational moon for the movement of the wave to ensure that the dam of your system is running smoothly. Next, so we show you the OTEC. OTEC is a very different things with the. Oh, sorry. I think I have another one video. I think maybe this is the last one related to the wave energy before we go to the OTEC. Okay. Let's hear this one together.
The water of the oceans of the world is almost always in motion, hardly ever interrupted. Waves break at the coastlines, sometimes strong, sometimes weaker. There is enormous energy potential available around the clock and free of charge. A potential that, if fully exploited, could satisfy 40% of the worldwide demand for power. This equals the output of 700 to 800 nuclear power stations. Hydro Wavejet is developing technologies to convert this inexhaustible energy into electric power without the emission of harmful greenhouse gases. The operating principle of this wave power station is as simple as it is ingenious. An enclosed chamber has an opening beneath sea level, which allows
managing your projects should feel more like this. That's why you need ClickUp. With ClickUp, when you want to
water to flow from the sea to the chamber and back. The water level in the chamber rises and falls with the rhythm of the waves, and air is forced forwards and backwards through the turbine, connected to an upper opening in the chamber. As it is compressed and decompressed, the airflow has sufficient power to drive the Wells turbine. It is a feature of the Wells turbine, named after its inventor, that it is driven in the same direction by both forward and reverse airflow through the turbine. Even relatively low wave motions can generate enough airflow to keep the turbine moving and to generate energy. This is how easily energy can be generated with a wave power station, day and night, all year round, as long as there are waves. The world's first power station of this kind was put in service as early as November 2000 on the Scottish island of Islay and has been feeding power to the grid ever since. Boyd Hydro Wavejet is convinced of the commercial potential of wave energy. We are certain that our wave power stations can make a significant contribution to supplying the world with climate-friendly energy. The global climate change affects us all. Our search for alternatives for emission-free energy generation has led us to the enormous potential of the oceans. The seas of the world hold tremendous energy that can be utilized, for example, in the tidal streams. Boyd Hydro develops a turbine for the utilization of these tidal currents, with which this enormous energy can be converted into electric power. According to expert opinion, approximately 400 terawatt hours per year can be won in this way from the seas of the world. The dimensions of a tidal current turbine are impressive. The turbine nacelle is almost 13 meters long, and the rotor has a diameter of 16 meters. In total, the plant is 26 meters high, which amounts to the size of a 7-story house. Once the installation vessel has reached the intended location for the underwater power station, the turbine is connected to a pre-placed subsea cable. For the future recovery of the turbine for maintenance purposes, guide chains are fixed to the foundation. The entire unit can now be immersed. After the underwater power station has reached the ocean floor, the turbine is started from the onshore control room. The sea sets the rotor into motion, and the turbine begins to supply electricity with a generation pattern following the tides, regularly, predictably, and reliably. Each turbine has an installed power of 1 megawatt. The tides change their direction of flow approximately every 6 hours. The special rotor design of the turbine allows flow intake from both ends without having to adjust the turbine. The rotor simply changes its direction of rotation. This means that no complicated equipment is required for blade adjustment or nacelle rotation. During the development of the turbine, special attention was paid to simplicity, robustness, and eco-friendliness. The design has eliminated failure-prone transmissions and operates without oils and grease. Seawater is used for bearing lubrication. Another special feature lies in the avoidance of complex and sensitive seals. This has been achieved by designing the generator components to operate immersed in seawater. Via the sea cable, the generated electricity is directly transmitted to an onshore inverter station, then fed to the grid via a transformer. This robust and simple subsea technology gives long intervals between maintenance and hence minimizes the utilization of extremely expensive marine equipment. When the tidal current turbine is due for maintenance, the facility is shut down and disconnected from the grid on shore. For maintenance, the turbine is lifted from the water. To achieve this, a service vessel positions a cradle over the turbine. Buoys connected with the guide chains during installation float to the water's surface in response to an acoustic signal, and this allows access to the guide chains. Sliding on these chains, a lifting frame is lowered and directed below the turbine by maneuvering the vessel. The hydraulic clamp closes and then grips the turbine nacelle. Now the guide chains are tightened and the turbine can be safely lifted to the surface and disconnected from the sea cable. All maintenance work can be performed directly on the service vessel, protected by the harbor walls. The rotor blades are removed. The turbine is lifted to the service vessel and put on mobile assembly carts. Secure on these assembly carts, the nacelle can be easily disassembled, allowing good access to all components that require maintenance. Even in small harbors with little infrastructure, the components can be exchanged easily and quickly. Comparatively simple equipment, for example, a mobile crane. After completion of the repair or maintenance work, the turbine is returned to its location at sea and reinstalled. With its new tidal current turbines, Boyd Hydro is making a vital contribution to the development of new and emission-free energy generation. The company regards itself as a pioneer in technology developments aimed at the utilization of all kinds of hydropower. Boyd, engineered reliability.
Okay guys, so that's the thing that's mentioned just now regarding the operational parts. So just imagine we need to have the very good facility to do all the maintenance and everything. We have to prepare all the equipment to submerge, to repair, to replace everything. So that's the challenge. So that's the challenge. If you want to go for the Tidal or OTEC, Tidal Energy, so you need to prepare those facility to ensure that you can sustain all the power output in terms of the generated power. So next, after we discover related to the tidal and also for the wave, so let's have a look related to the OTEC, Ocean Thermal Energy Conversion. Okay, OTEC. So OTEC different with the mechanism of wave and tidal. It more related to the temperature difference between the underneath cooler temperature and the upper surface of the high temperature. So maybe you can have a better understanding by looking this short video. Just to check the check column. Okay.
Hello and welcome to Just Have a Think, and the first programme of 2019, a year that already looks like becoming another historic period of time for all the wrong reasons, with record low winter sea ice cover in the Arctic, an El Nino that's threatening to nudge global temperatures up to levels that might rival 2016, and a world economy on the brink of a global crash. Oh yeah, and here in Britain, small and apparently completely unresolvable issue of Brexit, which needs to be decided one way or the other by the 29th of March. In the face of these looming calamities, here at Just Have a Think, we're going to start precisely where we left off just before Christmas, which means we're going to be taking a close look at some of the global climate change mitigation technologies that are either at inception stage or in development, or even coming online at scale in 2019. To kick us off, we're going to be examining a technology called Ocean Mechanical Thermal Energy Conversion, or OTEC. The system is the brainchild of Patrick McNulty in the United States. Patrick has 33 years of experience in power plant operations as part of the Chemical Demilitarization Program of the United States government, and also the Florida Power and Light. This is Florida, Miami to be precise. Patrick's insight and invention takes us out from this coastal city and into the deep waters of the Atlantic, where we arrive at what, at first sight, appears to be just another boat in the ocean. But this vessel isn't designed for transport. It's designed for power generation and climate control. To discover the enormous potential contained within, we have to take a look underneath. The open sea here is up to 1,000 meters deep. That's well over 3,000 feet. At the bottom, the water is a very chilly 6 degrees Celsius, but on the surface, it can be more than 22 degrees or 72 degrees Fahrenheit. Gulfstream passes the Florida coast, traveling at around 6 miles an hour, 24 hours a day, 7 days a week, 365 days a year, as part of the global thermohaline circulation. So let's take a closer look at the system to understand the truly transformational capabilities it offers. Down here, we start to get an idea of the scale of the construction. The main tunnel is over 30 feet or 10 meters in diameter, capturing enormous quantities of constantly flowing, constantly warm water, with a travelling filter screen to keep out contaminants and ensure sea life is not swept into the tunnel. In the centre, a second vertical tunnel brings cold water up from the deep waters below. We'll return to this later. In the meantime, we pass by a narrowing of the tunnel known as a venturi. This narrow section creates a drop in pressure which causes an increase in flow speed. Keep that in mind for later too. But still the hidden potential of this concept has not revealed itself. So let's go all the way down and start at the bottom. Down here, the water's very cold, only about 6 degrees Celsius, or about 43 degrees Fahrenheit. A 90-degree bend at the end of this 2,000-foot-long insulated pipe allows the deep waters of the Gulfstream to be captured, once again with the additional protection of a mesh filter, this one being cleaned and maintained by a submersible vehicle. As we follow the water up toward the top of the vertical tunnel, we reach the lower section of the yellow pipework we passed by earlier. Inside this section, there are 4 giant condensers containing a Freon refrigerant fluid. Freon boils at comparatively low temperatures, typically around 57 degrees Fahrenheit, or just below 14 degrees Celsius. Because the pipe is insulated, the water being drawn up from the deep is still cold enough to keep the Freon in its liquid state. But as the fluid flows upwards, it's drawn into evaporators that are bathed in the warm surface water. This takes the temperature of the Freon above its boiling point, and that means a change in state from liquid to gas, which in turn causes an expansion and kinetic movement. The gaseous Freon now takes the course of least resistance, which sends it through the pipework up onto the top of the platform and into the electricity generation plant, where it passes over a turbine, which in turn drives an electrical generator. Now, some of you out there watching this might be yelling OTEC at the screen at this point. Sure enough, ocean thermal energy conversion is indeed exactly what we just described. The system has been known about since the early 20th century, but the problem that all OTEC systems face is that the majority of the energy produced by the heat engine is used up to run the powerful pumps needed to push the fluid around the system and to run all the ancillary devices. The result is efficiencies of only about 8%. Patrick McNulty's OTEC system exploits 2 natural phenomena of the Gulfstream to overcome this power loss issue. Let's quickly remind ourselves of the schematic we looked at earlier. Because there are 2 equal forces being applied to the top and bottom openings, but only a single outlet, the one on the right-hand side of the top tunnel, there'll always be a pressure differential that draws water up the vertical pipe, just like a siphon. And that means there's no need for a pump to do this job. That is a major saving in system energy requirement. While we're here, let's also consider the temperature of the water leaving the right-hand side of the horizontal tunnel. It will, by definition, be at a lower temperature than the water entering on the left-hand side of the horizontal tunnel. The exact temperature can be carefully controlled by a 3-way damper where the 2 tunnels meet. With enough of these systems in operation, a significant cooling of the surface water could be achieved, which in hurricane-prone areas like the Gulf of Mexico could reduce the strength of the storm to a lower category, reducing the risk of collateral damage at landfall. And at a very, very large scale, something in the order of many thousands of platforms, enough surface cooling could be achieved to produce a short-term lowering of global temperatures, buying our species a few extra decades to sort out our fossil fuel addiction and get our CO2 emissions back under control. Returning to our model though, you'll no doubt have noticed that the system does need circulation pumps at the top end of the condensers to help push the liquid Freon up into the evaporators. And the sharp-eyed among you will also be asking where the power for the travelling curtain and any other ancillary items is coming from, if not from the heat engine itself. And that leads us to the second unique differentiator between the standard OTEC system, Patrick McNulty's OTEC design. You remember we looked at a Venturi section in the horizontal pipe earlier on? Well, nestled inside here at the narrowest point is a 1.5 megawatt tidal turbine, turning constantly in the never-ending flow of the Gulfstream. Because of the reduction in pressure that the Venturi section creates, the flow rate increases, keeping the turbine turning at a healthy speed. So unlike a normal OTEC system, the Gulfstream itself, via this turbine, is providing more than enough power to drive all the necessary pumps and filters within the system, as well as run the light and power for the facility, and most probably will still have some residual power left over to feed back into the grid. And because we have a large expanse of flat roof, solar panels can be exploited to provide yet more grid electricity when the sun's shining. There's enough thermal energy in the Gulfstream alone to power the human species 100 times over. This stretch of water could easily accommodate many thousands of these platforms, providing all the energy needs for the entire United States of America, and and the system could be implemented in several other ocean locations around the globe where similar flow and temperature differentials exist. I discussed OTEC systems in a recent interview with Professor Peter Wadden, and he recognised the potential benefits of McNulty's additional design features.
This sounds even more interesting because it's an OTEC scheme, but you're solving the problem of loss of energy.
Yes, I think it's quite exciting. I must admit that I was interested to hear your.
Yeah, it's exciting and it's surprising that nobody explored that before.
Now, just for full disclosure, this is a project that I've also been working on with Patrick to get some of the drawings done as well as the animation that you just watched. The project's now moving on to the next stage of development where efficiency and energy generation calculations. So Patrick is now actively seeking academic institutions to join the project and support the research. So if you're working or studying in this field or a related industry, leave a message in the comment section below so that we can get you connected. Lots more technologies coming up in the next few weeks. If you haven't already done so, please do subscribe to the channel and hit the notification bell to get alerted whenever a new program comes out. And that is as simple as clicking here. That's it for now though. Happy New Year. Thanks very much for watching. Have a great week. And remember to just have a think. See you next week.
The world had made a deal. In December, the world leaders came to an agreement to stop climate change. World leaders congratulated each other because lengthy negotiations had finally resulted in the decision to prevent a catastrophic warming of the Earth. A political victory. But was it? This story tells us why now, after 20 years of ineffective.
Okay, guys. So that's the briefly explanation related to the wave, tidal, and also the OTEC. So if you can see from the video related to the OTEC, so you might see the facility or the technology is required to ensure that the successfully of the system. Okay, even we are in the Malaysia, I mean the Peninsula Malaysia and also Sabah Sarawak, surrounding with the ocean or the sea. But then we just focus on the part related to the hydropower. Okay, hydropower instead of the tidal wave or OTEC. Okay, so that's what we can conclude related to the renewable energy, specifically in Malaysia. Maybe we can ask either Jia or Khalid, representing Yemen and Sudan. Is that they have the tidal wave or OTEC resource for their renewable energy? Do you have that kind of facility, Khalid or Jia? Okay. No? Not sure. Don't know. Okay, never mind. Okay, no problem. Not so sure. Okay. Okay, very, what we call that? Very transparent. GN. Okay, but then I'm not so sure whether I think the best part to investigate the potential of using this kind of approach, renewable energy, using the wave or tech for the OTEC and Tidal, you need to ensure that you are surrounded with the sea, ocean, sea. Okay, because normally they will install most of the facility nearby the coast. Okay, Semenanjung, the coast of the area. If you do not have that kind of condition, you might go for other resource of renewable energy. Okay, Jet and Khalid, as simple as that. Because you just imagine Malaysia is the place that surrounding by the sea or ocean as well. Do not use the OTEC, tidal, or wave as a part of the renewable energy or the part of the energy source. Okay, so it depends how your government consider the potential by assessing the geographical condition, and yet need to consider the best how or with kind of what facility you want to invest your money to produce your sustainable energy, or else you may go for the running loss due to the maybe not sustainability of the facility, or maybe wrongly justify your potential of renewable energy. Okay, so I think that's the very basic related to the principle of the renewable energy in terms of the attack, tidal, and the wave. Okay, guys. So basically, we are almost completed regarding the lecture by this semester, which is we already completed the things. We just need to have another 2 quizzes or 2 or 3 quizzes, depends. The third and for the fourth quiz is confirmed, but the fifth quiz depends. In terms of my consideration, if sir want to make the fifth quiz as a bonus for the quizzes, so sir will conduct that. If not, we remain for the next quizzes, which is tomorrow, Tuesday night, and also for Wednesday. Okay, so that is the 4 quiz, third quiz and the 4th quiz. Okay, since we have another Friday and also the next week session, so sir already select the, I would say, the better version of your assignment related to the renewable energy. If you are still remember, we have the topic with been executed by the 2 groups, right? Let's say topic A have been done by the group A and B. Topic B, another topic, we go for the same with the C and D. Okay. Yes, Chuheng, sir plan to conduct the quiz 3 and quiz 4 on Tuesday and Wednesday from 8 to 10 p.m. Is that okay? Is that okay, Chuheng? But I think the quiz will conduct roughly not more than 30 minutes. My idea, let's say you can start to open or to answer from 8 o'clock, but I recommend that you guys from 8 you just go through your lecture note, everything, and then after you think you have a good preparedness on that, so you may start your quizzes. Okay. Because the quizzes is not that much, maybe 15, 20, or not more than 30 minutes. Okay, if you do it together, it might be less than 5 minutes. So that means it can be umbrella. Again, is that okay, Zakan? Okay, no worry, only one set of question. It's not macam, let's say we have a 61 student, so set for 61 different of set of question. No, one set of question for 61 students. Okay, I think I need to off record this one. Okay, I stop.